in space, so vectors in 3D space. So in space, a vector v in standard position with terminal point A, B, C is denoted in that component form as v equals A, B, C, and has a magnitude of, and this is the distance formula, just a different version of it, A squared plus B squared plus C squared. Okay. Using the standard unit vectors, if you had I would be the first component, okay, so it's going to take that 1 there and zeros everywhere else. J would be that vertical component, or that second number would be 1. And then you have the next variable we haven't done is K, and that would take basically place of the Z. So the other way it can be written is just like this. Okay. All right. Now, given any vector with the initial point of, the x1, y1, z1, and terminal point of x2, y2, z2, you can write the vector in the component form like this. You can put parentheses around it. I'm not doing it. There's no point. That z and that 1 look the same. Okay. So let's go ahead and do this page. I don't really know how it breaks off, to be honest with you, because I didn't look ahead. And then we'll do another video with the next page. Okay, so it says find the magnitude of each vector. So pretty simple. Okay, you're going to take 4 squared, negative 2 squared, and negative 6 squared. Okay, so 4 squared, 16. The negative 2 squared would be 4, and then you would have 36. If you add that all together, you get the square root of 56, and I'm going to go ahead and simplify that. So 56 divided by 2 is, what did I do? Sorry. Is 28, and then divide that by 2, and you get 14, and divide that by 2, and you get 7, which is prime. So that goes to the outside, and the 14 stays on the inside. You could get the decimal answer too, which is like 7.48, if you really wanted to know it. Okay, I would like for you to do number 4 on your own. So go ahead and try to do that. It's just a different form. It's the same process. You just use the coefficients, okay? So go ahead and pause the video now. Okay. Now that you've come back to me, let's go ahead and figure this out. So you would have negative 7 squared, which we can do this. This is 49. You'd have negative 1 squared, which is 1. And you'd have this squared. So you square the 3, which is 9, and the square root of 2 squared is 2. So you get 18. If you add all that together, you get 147. Not 147. Wow, no, sorry. Looking at something else. You get 68. So if you go ahead and simplify that, let's say if we divide by 2, 68 divided by 2 is 34. Divide that by 2 and you get 17. And you're done because that's prime. So you get 2 squared is 17. Oops, I wrote a 4. Oops. And that is equivalent to 8.25. Okay. So in the next question, it's asking about component form. So it wants you to write the component form with the given initial and terminal point. So that is right here. Okay. Ooh, wow, that was supposed to be a star that didn't make a star. Okay, so basically you're just subtracting the terminal point, and we know this is the terminal point because of the B. We know that's the initial point because of the A. All right, so it's not overly complicated. So to find AB, you just take 0 minus 7. Okay, and we know that that is I started writing this on the wrong thing. I was so confused. I was like, what am I doing? Okay. Sorry. Let's scroll up so I'll do that again. So we're trying to write this in component form, which is like that last thing I put a star on. Ignore this. Okay. So we're going to take negative 3 minus 13. Okay. And we can do that in our head. So that's negative 16. We're going to take, there's just be a comma there. You're going to take 5 minus negative 7. So it's going to give you a positive 12. And then negative 9 minus 1, which is going to get you a negative 10. And that's it. That's all you have to do. I don't even need all this space. And if you want to show more work, you can, but it's really that simple. So Okay, now it says write AB as a linear combination with the given initial and terminal points. So basically what you're going to do is you're going to do this step, and then we're going to do the I, J, and K. So if we have AB, the first thing we're going to do is the 0 minus 7, so negative 7. We're going to do the 6 minus 2, which is 4, and then negative 3 minus 1, which is negative 2. And that, I don't know why that looks so bad. So if you want to write it in that linear combination, that's where the letters are involved. So, whoa, guys, whoa, I'm losing it. Okay, so that would be negative 7I plus 4J minus 2K. And that's it. Simple as that. Right? So we're going to split this up again. The next video is going to have the next page. So just follow the link that's going to be in the left-hand corner.